Give me a new. Now, let's say you have a list of all the stock names, something like that, in your data set.
Yeah.
You could do something, for those who, if you've ever seen dput is a very helpful function that if you have an object in R and you want code that will generate that object, right? So in this sense, you pulled from Wikipedia to give you X, right? So you don't just have this like thing all listed out, but you'll have 500 a vector of length 505, right? And you want to be like, well, I just want to hard code that into my code to just say this is list of stocks. So one of two ways: you can either save it as an RDA and zip it with your homework, which is probably the easiest, right? You just zip the list of stocks. You don't actually pull it from Wikipedia. Or the second thing, you just use dput and put a big chunk of code in there, right? Because it'll just be like 500. And just say, like, list of stocks equals, and you can copy from the console to give you just that whole list of stocks. Versus having to, like, make a vector. Does that make sense? So, like...
So what is dput actually doing?
Here's an example of when not to name your stuff really in a silly way. Stock market. Okay. Just grabbing some names. Right? It's got this stuff. That's not even... Okay. Never mind. Just save it as an RDA. Because not only you... Okay, so what... I'll show you what dput does. This big crazy thing, right? If you copy all this text, right? This is... Hold on, let me go to the very, very top. It's a big data frame. That's a problem. Let's do it here. So you see it says structure and then list and all this kind of stuff.
Yeah.
If I copy this whole thing and I assign it to an object in R, like I say x equals this or something like that, in my code, that'll give me a data frame which is exactly Wikitabs. So dput took an R object and gave you all the R code needed to make that object. Does that make sense?
What's different than just saving it as a data frame?
One is saved in like an actual script. The other one's saved as an object.
Oh, okay.
There's not much. Usually, there's not much use to it. But sometimes, like for example, you run like a table or like unique Wikitabs ticker symbol. Wikitabs sector. What is it? Sorry. Like, there we go. All right, so let's say these are the ticker symbols that are of GICS sector 1, whatever that is. I don't care, industry or something. I don't know. But let's say, right, this just prints it out. What if I actually want to save that vector, right? But like, I don't want to do it dynamically in code. I want to like just get that list of things that I can use. Like, for example, if I want to copy and paste this and be like, these are the ones I want to subset. And sometimes, there are reasons sometimes, I guess I'm trying to think of a scenario when you want to do that. That, like, let's say you read in data, and here's an example. For the data set you have, you wanted to get, you had like a list of things that you, like a way of naming conventions or something like that. Male, female, for example. But let's say it was coded like 5 different ways, right? And you have rules to fix those 5 different ways, right? Now, instead of saving an RDA with the 5 different ways it was coded, you can just say, like, if it's not in these 5, you should error because something changed dramatically. Does that make sense? So you just want to think. Usually, it's not good for like super big things, but it is good to for example, say if male. Let's say male was if. So you want to say like male equals. Right. So like if you want to say is male, like in your next iteration, right? You want to say something like this. Are they all in this type of form? Right? Because you're like, I only made rules to handle these 3.
Yeah.
Right? If it's something else, then you got to break. Then you want it to stop. But like for example, if you wanted to if you could just like table male or unique male, and let's say this wasn't like 5, this was like 20 or 15 or 10, something like a small range, and you're just like, I want just R to give me that vector so I can just copy and paste the code. So it deconstructs R objects into R code.
I gotcha.
Okay. I probably should look at the help. It probably like tells you.
Yeah, I pulled it up. But...
Yeah, I don't know how informative it is. Okay, now we got model. We have something. Okay, the things you need, right? Let's talk about the things you need for the code and the things you need for the posters. Does that sound good? Okay. So you need a function that takes in pretty much what I would say a date and creates. So a function that creates dates. What does it give out? What does it do? Creates x's. And with those x's, predicts y. Y, I believe, should be a ranking. Yeah. So here's where I don't know. I will ask Jeff before tomorrow, just because at the end of the day, we always said you needed to rank them, right? But the question is not really does it rank them, it predicts which one is your best stock, right? So, but the criteria, that's pretty harsh, in my opinion, right? So let's say, for example, you tell me stock A is going to be the top stock, but it was the second top stock.
Yeah.
Granted, you failed on the hard criteria, but like, is it in the top 5?
Yeah, I mean, like, for the SOM code that I ran, predicting the actual rankings is incredibly variable.
It's incredibly
because like you can't even get good predictions for the actual returns, and the variability around those I think is such that if you have like a small change in the prediction for that, you're jumping like hundreds of ranks. So I just don't think that there's enough variability across all the returns to be able to like suss out like what actual rank they are.
Well, I will say that might not be the best model for this problem.
Yeah.
Right?
I mean.
And yeah, I mean either so you might like if we were to like continue this project in like real life and like an actual like something where you might want to publish it, potentially looking at stock specific models might be more interesting, or you might be able to leverage some information with that. And for example, you might be able to put a random effect for stock, especially in this case, because of what we just said, that the S&P is not going to change, right? So you're not going to get a new stock coming in that isn't in your set. But okay. So I believe it should predict ranks. And Jeff and I, so it should be like 1 to 505. Right? It should tell you, it should be like stock name or ticker symbol, whatever. The first column should be the ticker symbol. The second column should be the rank. For
So
that day.
You're talking like you conceptualize the model as actually your Y is actually the rank and not the return.
No. Not necessarily. Sorry.
You're talking like the end point of what you
Predict.
want to see.
Like I'm saying, like input, output.
Okay.
So input is a date, right?
Yeah.
Output is the symbols and their ranks, right? But so that's the criteria Jeff made up for this problem, right? Tell me which one's the best.
So if you have separate, like if you have more than one model, and if one model is better for predicting like the good ones, and one model.
You have one model. At the end of the day, you provide one model for the code.
But at the end of the day, what is important is like 1 to 5 ranks for one
Mhm.
stocks for like the top 5 stocks, right? So
Well, it's top one stock, but
top 1 stock.
top one stock. But that's what I'm saying is now for the poster, I believe maybe top 1 is a really hard ranking, right? It's a really hard criteria, right? Because especially for example, Gina, if you only had one day to estimate how good that was, and then you got it wrong, your best guess estimate is you're 0% accurate, right? What you can do, especially if you stop from the 14th, you can do for like a couple days and look at the misclassification rate there. So for example, Gina said she had data from the 14th. So we can go 11, like 15 to 11, 21, right? Like a week of data, right? This is for the 1 day prediction. And you can say percent times correct. And now, here's the thing. In my opinion, if that's 0, I'm going to put 0. In my poster, I got it wrong every time. That's just the way it went.
Yeah.
Now, it's a harsh truth, but like, I firmly believe that's something I care about. That's something the criteria we talked about. So I want to know that number, right? I personally would want to present that in my poster, even though it makes my model look bad.
So it's percent times correct for the first prediction.
So for rank 1. Now, there are other criteria that people specify with terms of rank. I think it's like the order 1 rank, but pretty much the other criteria is like, is number 1 in top blank ranks? And they usually do like 5 and 10. Something like that. Where they say,
So like your predicted one versus the true.
Yeah, is like the best stock in my top 10. Is the best stock in my top 5. Does that make sense? So it's saying like, although I didn't get the numbering 1 to 5 right, I got the number 1 stock in that 1 to 5. Or in that 1 to 10. Somewhere. And by the number 1 stock, that's the truth. Right? And the 1 to 10 is my rankings. Does that make sense? Okay. So I would definitely specify this criteria in your poster. And I don't know how we're going to judge, like, if, actually evaluate functions. But I'm going to talk to Jeff, and I think we'll probably use, all 3 of them. We'll look at probably all 3 of them. Just be like, is I don't believe you guys don't need to create a function that gets the true data. For example, like we have code, like we can get, like if we have a day and we have the S&P 500, we can get like the true rankings. Is that clear?
But I thought we need to know that anyway.
Sorry, I mean like all you need to provide to us in the code is a function that gives us this out. And we can evaluate this function just getting the true data. Does that make sense? So like if I specify today, today's date, like I can grab the true data off QuantMod. I'm saying you don't have to do that additional stuff. It just has to get me the ranks for this day from your model. Okay? It doesn't have to evaluate how well you did or not. Does that make sense? No? Yes?
Well, yeah, I thought I got it, and then you said we don't have to get the data off QuantMod, but we will.
No. You need the data off QuantMod to get this.
Yeah.
You don't have to get the actual returns for that day in question to evaluate if these ranks are good or not for the function we want. So all I want from you, like if I give you a date, I want the symbols and your predicted rankings.
Yeah.
Okay?
Yeah.
And then I have the real data. That real data, like I can get. You don't need the function that gets the true returns, the true rankings. You don't need a function that gets those. For your project, for your poster, you do, because you're going to have to evaluate your model.
Okay.
That's
so you're
all I'm
talking about like historically, we can go back at previous days and look at if we were correct
Yeah.
or not. But like
But
we're
when-
sort of like treating it like a Kaggle competition where we wouldn't know what the true data was. Like you're the ones who have that. Okay, gotcha.
Well, I mean, most likely you won't even know what the true data is right now because we'll probably do it in the future, right? Yeah. So, okay, so I think these are two. So now this is kind of like, I would say, two relatively good criteria to say, is my model doing okay? And then, but I would say, a lot of people have been looking at mean squared error for the predicted. So if it were me and my model didn't predict on the ranks or predict on this 0, 1, is it best or worst, I would still probably put the mean squared error for my predicted returns in my poster.
Yeah.
Because I'd be like, well, maybe this wasn't. I mean, if I went that way, and that's the way I probably would have started this project, I might have just been like, maybe that wasn't the right way to go, and the variability around my predictions are just too high to really get in these top 10. So, this model is really probably not so bad, and by not so bad, I gave a root mean squared error or some estimate of how bad it is at predicting whether, like, the actual return with some variability, but when you estimate that, there's more variability across stocks than in my prediction. Or the day-to-day variability is pretty high, so my prediction can't really overcome that in the rankings. Okay, so this is for code, right? And for poster, I would have these. Maybe a root mean squared error. And the other thing is, you can put it's going to be hard to put, I think, some variability estimates on these, right? Because, for example, we did this. We have 6 data points, right? Like we only have like this can only take, you can only be correct from 0 to 6 times.
Yeah. So where does the prediction interval come into all this? I think that's also where I'm getting confused. Like where that comes from.
Yeah.
Because I've been conceptualizing it as prediction interval on the return estimate, but if you're talking about ranking.
That would be a different model. The ranking is a different model, but the question is, right? You have an X beta, right? Let's say it's a linear model.
Yeah.
Let's make it simple, right? You have an X beta. That takes into account no variability of the Y, right? In some sense, sorry, beta hat does, but I'm saying it doesn't take into account the fact that not only are you trying to predict some Y, you're trying to predict some Y in the future, right? So there is the variability around this, and there is the variability of y, right? So if I were to predict a return, x beta hat's always the same, right?
Yeah.
So if you're ranking strictly on the linear prediction, right, then it doesn't matter. Prediction interval, confidence, in any interval that you're going to say for these rankings doesn't matter because you're not doing an interval. You're just doing the x betas and ranking those,
Yeah.
the linear prediction. Now, there's like a difference between, a confidence, like an interval around this and an interval which takes into account this. I think from your model though, if they're all from the same, I'm trying to think about that. If they're all from the same model, if this is going to matter. But what I'm saying is, so there's predict, right?
So like when I run GAM and I do a prediction, there's like an option for SE fit. Is like that what we're supposed to? I think I just don't understand where the actual interval gets calculated.
That would be what it's from.
Okay.
So SE from predict with SE equals true.
Okay, so then that is our interval then. That would be an interval around one return.
Correct. Let's see, predict that GLM. So you can get the standard error.
Yeah.
Because another way I would think about I personally would think about ranking them, would be not just to rank on x beta, but to predict on, for example, the lower limit of the prediction interval, right? Because let's say two stocks predict pretty closely together. Like one is 1.05, 1.05, but the interval on this one is huge.
I see. So then you would rank them based on the lower end.
Based on that.
I see what you mean. Interesting.
Because let's say we were doing a little bit different of a problem and said, I want to make money, right? I want to predict a stock that's going to have a return above 1, right? And I got a prediction intervals, and if one was look like, yeah, it's definitely going to, go up by X beta. But if the variability around that is huge, I'm probably not going to invest in that stock. It's a high risk stock, right? In the sense, it's most likely going to go up, but the variability around it could go up, it could go down. We don't really know what it's going to do. And so that's what I was thinking, taking like a lower limit confidence in, prediction interval. So again, you have to, when you say for a linear model, and I'm not sure with predicting with other functions, with other models, you can usually say interval equals prediction. All right, let me see. Well, I wonder if you even have to do.
Because like, what?
I don't think you have to do.
SE fit equals
No,
true,
I don't think you have
so-
to say SE fit at all.
So then,
I think you just say. That's what you do. Interval equals prediction usually. That gives you the fit, the lower, and the upper bound. So, for example, like this one, like the fit here is like almost -3, -2. I'm not sure in the linear case if there'll be like a 1-to-1 correspondence between the rankings. Like that, like if you ranked on one, it would be the same thing as ranking on the others. Do you know what I mean? That like the variability of X. Let me see. Rank Apply rank to rank. Yeah, in the linear model case, I think that won't change anything. But depending on how the variability of X beta is derived, they could be different, right? The rankings could be different, right? Because in a GAM, for example, you might have less variability in prediction at like really high values, or really low values, or values in the middle, or something like that. But in a linear model, they're all the same for prediction. The rankings of prediction intervals versus the rankings of X beta. Okay. So I would say these are some good criteria.
So we basically are doing that though for the daily return and the 5-day return. So we're going to have two sets of information.
Sorry, yeah.
Can you explain like how all that works then with fitting the models? Because I think I'm going to be using the same model for both, but would you fit it again? Like you'd have a different model fit depending on whether you're predicting for daily or like.
Yeah, so.
And like how does that work for your training and your test sets? Like you fit it again on the same test set, or like you have to set aside a different test set to test it?
No, I don't think you need. No.
Okay.
I don't think you need a different test set, a training set. You would still, I mean, the models might be totally different, right? I mean, like, I would probably.
I think they kind of have the same. Mine have the same variables.
If they have the same variables and you did some selection procedure, they could come out differently. I'm saying.
You mean the beta hats?
Just the X's you chose.
Okay.
Right?
Yeah.
Like for example, I might do 4 days before this return in the day 5 model when I wouldn't really do that for the day 1.
Because I did that in the day 1, so like everything I think I would have included for the 5-day, I sort of already had included.
Yeah, and so if you don't select different models, then it's fine.
So then you would just run it.
Yeah,
you're just Y. In this case, the only thing changing is your Y.
So you would just run it again.
Yeah.
So when we use the same model, do we predict day 1 and then put that into your new data set, and then predict day 2 using all the data?
Why? I only want ranks for day 1 and day 5. So you don't there are ways you can think about doing this. You can say. Okay, so in one instance, you just take Y, and that's your day 5 data, and you predict on that. Another method to use is you predict day 1, predict day 2, predict day 3, predict day 2 using the predicted 1 day values. Same and similar here, and you predict day 5 based on the other information that you got. But these are predictions, right? Versus them being real data. So there is a method to go that way.
Is
I
that
don't
a
know if
valid method?
I think it's a valid method. I don't know. I mean, it's a little bit. One, for prediction, in my opinion. So let's go with the stock market approach. Does this make you money? Okay, then I don't care. I don't valid or not in some respects. There is some problem in the sense that we don't take into account the variability because these are predictions. We treat them as real data when they're not. Right? Also, one of the problems is if your covariates, for example, are like the price of the stock, right? Or like the volume of the stock, right? Then you would have to get predictions for those things as well. So in the case where Y day -1, right, is just one of your predictors, or just where the lagged Y's are predictors, this is totally fine and straightforward. You have one model for this, right? One model that says predict me a Y, predict me a Y, predict me a Y, predict But I'm saying, like, if your covariates have other things that aren't straightforward to get, does that make sense? Like the volume, the price, right? These technically you can get the price by back transforming the return and multiplying it by the price. Or something. Like the sector's not going to change. The month you already know. The year you already know. But like if volume is one of your predictors, you have to have a way that for on this day to get the volume of the stock to predict day 3. And similarly for this one. Does that make sense?
So what would be like the other way?
That you have a model and you have all these predictors and it's you have this is 1y, this is y2. You build a model of your data and you predict on y2 and you predict them. These are 2 separate models. They can be where it's like y1 equals like x beta hat or x beta plus epsilon, y2 equals z beta plus x. Where this can be x, it might be x, it might be all the predictors. It might be where z is a subset of x, right? Where there's just a couple predictors. Or you can actually have it where you added predictors for the other model, for the
So
data.
build 2 separate models that predict.
They can be separate, they can be the same. Sorry, they can be the same functional form. You'll get different betas if they're the same. Right? Because it's a different y, so you'll get different beta hats.
But then, just to clarify, if you are predicting y1 based on your lags, then you won't be able to use the same.
It won't be the same model. Well,
So,
it's the same. It can be the same model, but you have to add a procedure on top of that, right? This stuff isn't, right? It's just x beta a bunch of times, right? So like, let's say you have this one model that predicts the next day,
yeah.
and it doesn't matter on volume or anything like that. X beta, you get x beta x1 beta hat x2 beta hat,
Yeah, so you.
and then you predict, and it's like, you know, like x plus, I don't my notation is terrible, but it's just pretty much you use this to get this, you use this to get this, you use this to get this, you use this to get this,
Yeah.
and then you get something like that, whatever.
That'll be one model, right?
It's still one model, just in order to get day 5, you have to run them up, you have to predict 1, 2, 3, 4, 5 times, but every time you use the prediction, the covariates depend on the previous one. So it had to be it's an iterative procedure.
Yes.
But it's still one model, technically.
So that's one way of predicting.
That's one way of predicting. Say, I'm really, really good at getting the next day. And I'm pretty sure that my next day prediction is really good. So I am comfortable putting that in as the estimated return because I know it's so good. I mean, I know like this data is highly variable. So getting a model that you feel very strong about that is a really good prediction is hard. But I'm saying if you think that like let's say you got really slow root mean squared error for the predicted return, and in that model only things you really care about are like the day before predicted return, the month, the year, something that doesn't have to be necessarily estimated from the data or given to you, like in the sense of the volume. Then you only need so by that I mean your model is truly beta naught plus, let's say, beta 1, y negative 1, plus beta 2, y negative 2, where this is 2 days before, right? And then you have some other predictors where this is like sector, this is like year, this is like month, season. Does that make sense? So you can have just when you go to actually predict this, you don't have true y values in there anymore. You have the y hat values.
Yeah.
Yeah. for day 5. This only matters about day 5. Pretty much day 1, you have all the data. Sorry, you have all the predictors you need. But with day 5, if you're going with this procedure of an iterative approach, you need to put stuff in here to get a prediction, right? And these things come from.
What if I don't want to use the same model? If I want to use like a different model, then all the data that are available is like day like -5, right? So everything would be.
Everything is. If you want to do a different model where y2 has a different functional form, just you have to have everything. Like so, there's a day 0, right? There's day 0. And you have all the data you're going to ever have for day 0, and you're going to predict 1, and you're going to predict 5.
Yes.
So everything you have for day 0, you have for day 1. All the data you have for day 0, you have for day 5.
So,
But like you won't have, for example, day 4
yeah.
volume of the stock, right? Unless your procedure somehow built that into it. Which I mean by that I mean you have a model for Y, you have a model for volume. And so you put in here, if you had a volume, for example, you have to get a predicted volume on day 4, for example.
Yeah. Okay.
So that procedure is more complicated. It's probably, in some respects, if you thought things were going to go up and day 5, for some reason, so why would you maybe do this procedure versus another, or just predicting straight on this, right? We think 5 days ago, things could have drastically changed. And not drastically, I mean things could have changed slightly that would push you in one way or the other. Drastic changes, your models never pick those up, right? That's the whole point. That your model thinks your predictions think your model's right.
Okay. So this is along the same lines. Well, how do you justify your model? How do you say
Is it good?
or yeah? So why would any covariance be in your model at all? Should that?
So I would potentially think of looking at different models, and if you're doing it on the returns, looking at root mean squared. You have to have some criteria. So if you're looking at returns, you could do root mean squared error. Like if you drop out this predictor and it's better or worse, or you could do the rankings, the rank 1, rank 5, rank 10 predictions. So those are just criteria to say, do we need this predictor at all? Right? Because if it's the same or it's worse, then you probably don't want that thing in there. So you just need some criteria to choose to say, we're going to choose models based on this.
Would exploratory data analysis be okay for choosing?
Yeah. I think that's perfectly fine. I think it's hard to operationalize some of these measures in an EDA way in some respects, because it's I don't know if something can predict something, that's great, but will it actually contribute well to the rankings? Right? I don't know. Because really the thing that's very different about this problem than others, the predicting in the middle is not what you care about. You want to predict in the extremes, right? The high X betas. So, do you guys have any questions?
No.
Okay. Well, Jeff said people wanted to come with questions, so I just wanted to make sure if you guys had any you would ask.
Oh, and for the poster,
Mhm.
should that have all the components that you would want for a paper? So say objectives, data, methods, and results.
That's a good question. That is a little bit based on style, but I would say probably just having I don't think you shouldn't have paragraphs, in the sense of long paragraphs. I think posters are great ways to you don't have to write all this stuff. But that doesn't mean it's not the same as not being explicit. Just being objective. We want to predict best stock. That is in a poster, right? That doesn't take up a lot of space. It is very clear what you want to do, and then we're going to use S&P 500, right? That describes your data pretty well. 100 stocks. We're gonna only constrain to this, right? Like those things are usually like a whole sentence or like a whole paragraph in a paper or in a report, where it's just like a bullet point, just like data colon S&P 500, or like stocks lists stocks analyzed S&P 500, right? And I don't know. I have to talk. I'll have to get Jeff's response, but I mean, posters don't need to have the same level, the same amount of detail that like every single thing, like it should be clear that like if I say stocks analyze S&P 500, like that's not academic prose, but people get what you're saying on a poster, right? Like I can read that poster. So here's my best suggestion. Give it to someone who doesn't know about this project, and just be like, can you get the gist? Can you understand mostly what's going on? You don't need to know exactly what this model is, but just like think of the questions you would ask yourself. It's like, how did you choose that model? Like, okay, you did exploratory data analysis. Does it say that in the poster? Right?
So, but it's not going to be as explicit as we were in our papers.
No, it's really going to cut to the chase really quick, right? There's not going to be a long data setup. You might cite, like, I got the S&P from Wikipedia, so you'll have a set of references. Those, usually, if you look at posters, references are they're not sparse, but there's like,
Yeah.
usually maximum of 5, and they're like, references, in like a smaller font than anything else, right?
Would it be appropriate to have a link to the GitHub?
Yeah.
On the poster.
Yep. Totally fine.
What's that on the?
So the other thing I'll say, I'm not saying to do this, but just remember, I want to be, so this is not for necessarily this poster. I always put sources of funding on your posters. Sources of funding. And it's not like
Which we have none. We don't have any for this.
you don't have any for this, but it's like, if you're a PhD student, for example, you're funded by maybe a training grant or like a grant, like something like that. So even like, I would say if you're presenting at a small conference, always have that, like NIH grant numbers, that kind of stuff. Like this data isn't it's not collected under any grant protocol. But I would just have like NIH, grant number, like T32s for like training grants. But you'll notice it's like, these are kind of how like the setup posters go. It's like title, author, the Hopkins Shield, whatever that looks like. Sometimes maybe you have another logo over here, maybe not. But like, data, like methods are usually, especially for stat papers, methods are pretty much like, big thing here, where write model down. Or covariance, right? Like somewhere there, like intro. Intro is a pretty strong word. Usually I would say like objective. Objective is a much more understandable reasons to like what you're actually doing. I can't. Okay, I thought you were gonna. Never mind.
What?
I thought you were gonna take a picture of this. I was like, don't do that.
No.
I can't write like legibly. Yeah.
I already told her.
Yeah, so we'll go to the work. So definitely go see the worst stat posters.
You should say I'll find someone else.
So I would have conclusion, and I would have like results. I mean, it's still the same type of headings, but it's not anywhere to the levels, the specificity.
So for under methods, you have your model, you have your covariates if you're using any, and that would be all for methods.
Like, what criteria are you using? Like, okay, EDA. What is a rank? The rankings, right? What are those rank measures? Like, if you say like I'm using a in the top 5 measure, which just calculates is number number 1 true rank in top 5, in top 10. And what criteria did you use? You used 1 day to estimate that value. 10 days, your training, your testing, how did you split the data? Those are all methods, right?
And for sources of funding,